Good day, ladies and gentlemen. Welcome back, and we are discussing reactions. And let us start right away here with this consider. Consider the decomposition of solid calcium carbonate, predict the products, and then write the balanced equation for that. So we are talking about something called decomposition. Hey, I don't recall talking about decomposition last time. We said, hey, we have reactions and we have chemical equations, and we talked about how to express reactions through chemical equations. And then we said we had types of reactions, and one type of reaction we said we had was a synthesis reaction, right? And I said it takes the general form of A plus X yields AX, and the key here is you are making one product from two reactants. So we said, hey, there are 5 types we need to know. There's a metal plus a non-metal, and we've predicted that will make a binary ionic. There is a metal plus oxygen, and that will make a metal oxide. There is what? A metal oxide plus water, and that will make a base, a metallic hydroxide. We could have a non-metal oxide plus water, and that will make what? An oxy acid. And then finally, we can have a metal oxide plus a non-metal oxide, and that's going to make my polyatomic ionic compound. Polyatomic ionic, as opposed to my binary ionic. Good. And so those are my synthesis. Now, this time we want to talk about kind of the opposite, the polar opposite of synthesis. It is a decomposition reaction, or I just simply say decomp usually, and it takes the general form of AX going to A plus X. And the key here is I have one thing that is breaking down into at least 2 other things. Good. And the greatest thing about this is it is really just the opposite of my synthesis. So yeah, there are 5 reactions, but is it really difficult? Well, I have a binary ionic, and it's going to do what? It's going to decompose to form a metal and a non-metal. Good. Let's take a typical binary ionic. I have what? How about potassium chloride? Potassium chloride solid is going to be heated, and we could, if we wanted to, we could put that little thing there, and it's going to break into a metal, potassium, and a non-metal. Well, chlorine is always diatomic, right? Gas, so I'll need 2 of these and 2 of these. There we go. Woohoo! Next, how about I have a metal oxide. So this is number 1, type 2. I have a metal oxide, and it is going to decompose into what? A metal and oxygen. Good. So let's take our sodium oxide and let's heat it up. Hit it with heat. Zoink. And what do I get? I'm going to get sodium solid plus oxygen gas. Oxygen is always diatomic. I need 2 of these, which means I need 4 of these. There we go. Wow, piece of cake. Man, I'm glad I memorized these guys, because if I memorize these, then I get these guys for free. This is almost like 2 for 1, right? Wow. Black Friday in chemistry. Number 3, we can have what? A metal oxide. What do you say? How about magnesium hydroxide? Excuse me, a metal hydroxide. And it's going to be heated. And what's going to happen? Well, it's going to break apart into water, HOH liquid, plus what? My metal oxide. How about magnesium oxide? Cool. Is that balanced? 1, 2, 1, 2, 1, 2. Yeah, piece of cake. Oops. Sorry, we should probably write this down, right? If I have a metallic hydroxide, which is also known as what? A base. That's right. Metallic hydroxide is going to decompose to a metal oxide plus water. Water. Wasser. Good. Number 4. What do you think number 4 is? How about an oxyacid? Oxyacid. An oxyacid is going to decompose into what? A non-metal oxide plus water. Okay, so let's take our, what is this? H2CO3 carbonate, 2 H's, so 8 becomes ic, right? Good, so that would mean carbonic acid, so I have carbonic acid. When we talk about acids, they are always aqueous. And so then, what do I make out of this? I need a non-metal oxide. Okay, I need a non-metal oxide. So carbon is my non-metal. It's going to be an oxide. And what makes the most sense? How about CO2 gas plus HOH? Is that balanced? Woohoo! It is indeed balanced. And number 5 on the decomp list would be what? A polyatomic ionic. It's going to decompose to form a metal oxide plus a non-metal oxide. So what's your favorite polyatomic? How about sodium carbonate? Sodium carbonate, solid. It's going to decompose, usually in the presence of heat, to form a metal oxide. What's my metal oxide? How about Na2O, solid, plus a non-metal oxide. What's kind of left over? CO2 gas. Yoink. There we go. Woohoo! And those are my decomp reactions. Now, what are the typical causes of decomp? Well, one, you figured out, is heat. Heat is often used to force a decomposition. And 2, the other one is electricity. Electricity. And we often refer to this as electrolysis. The electrolysis of water, for instance. Okay? Cool. Now let's see if we can answer our questions. Consider the decomposition of solid calcium carbonate. Okay, what do we have here? Solid calcium carbonate. It's a decomposition, so I know it's going to be one thing that breaks down into 2 things. It's calcium carbonate. How would I characterize calcium carbonate? Well, carbonate is what? CO3, CaCO3. That looks like what? That is a polyatomic ionic. And what happens to polyatomic ionics when they are heated? When they decompose, they are going to form what? A metal oxide plus a non-metal oxide. So I'm going to take my calcium carbonate, solid, and we are going to break it into a metal oxide, CaO. And now remember, calcium is a +2, oxygen is a -2 when they form ions, so it's a 1-to-1 ratio. And what's kind of left over here? CO2. And CO2 is a gas. Woohoo! Wunderbar! Next, you guys try this one. Well, we are going to intensely heat. Okay, so we know we're going to intensely heat solid cadmium hydroxide. There's only one thing listed here. There's no other reactants. So what must this be? If I'm going to take one thing and something's going to happen to it, it's got to be what? Oops. It's got to be decomp, right? Now, what is it that I have? Cadmium hydroxide. Cadmium hydroxide is a what? It is a metallic hydroxide. Good. And what happens with metallic hydroxides? Yoink. Let's find our metallic hydroxide. Metallic hydroxides. Metallic hydroxides do what? They form metallic oxides plus water. Good. Okay, so metallic oxide, metal oxide plus water. All right, so cadmium is Cd. Cadmium we know is always +2. Hydroxide, OH. My hydroxide is a -1, so that means I need 2 of them. It's solid. And what am I going to form? I'm going to form a metal oxide. Well, what's my metal? Cadmium is my metal. CdO plus what? Water. HOH. Liquid. Check to make sure everything's right. 2 hydrogens here, 2 hydrogens there. 2 oxygens, 2 oxygens, 1 cadmium, 1 cadmium. Yeehaw! We are right. Tie. Yoink, yoink. Good. Next. You all try this one. Well, it's decomposition, and I have solid sodium nitride. Okay, what's characterized sodium nitride? Well, sodium is easy. That is a metal. What about nitride? Well, nitride comes from what? Comes straight from nitrogen, so that is a non-metal. So what happens when I have what do we call something that is a metal with a non-metal? We call that what? An ionic compound. How many things are in this? Two. So it is a binary ionic compound. Binary ionic compounds decompose to form metals plus non-metals. So sodium nitride, so Na and N. Now, typically my sodium is what? When it is a cation, it's a +1. My nitrogens form what? -3s. So that means I need 3 sodiums, solid. What's going to happen to this? It's going to form my metal, sodium, plus my non-metal, nitrogen. And remember, I brought clay from our new. So that means nitrogen is diatomic, sodium is solid. We need to balance this. I have 2 nitrogens here, so what? 1 over here. I need a 2 here. Now I have 6 sodium, so I need a 6 here. So that would be our equation. Great. So that's all there is to decomp. Let's move farther. One more step farther. Complete the combustion. Consider the complete combustion of ethane gas. Predict the products and then write the balanced equation. Combustion. Okay. Is this synthesis? No, that's not synthesis. Is this decomp? No, it's not decomp. So what is it? Well, it is combustion. All right, that means what? That means we need some more notes. Let's go back up to our notes for today. Here we go. Type, synthesis, decomp. Let's go with another type, and it is, we're going to go blue. It is what? It is combustion. So, combustion. Okay, combustion reactions. Well, what are combustion reactions? Combustion reactions are high energy reactions. Usually you have a fuel plus an oxidant, and it's going to create lots of heat and oftentimes a flame. Now that's a pretty broad definition of combustion. We don't even know what it means. What is an oxidant? Well, we're going to get to that later in this chapter, but for the time being, we're going to narrow our discussion of combustion to one that's more common. And we're going to say that combustion, for our purposes, is a hydrocarbon or an organic compound plus oxygen. That's our oxidant in this case. And when we do this, we're assuming complete combustion. And when we have complete combustion, we always make carbon dioxide gas and water. Now, sometimes that can be water liquid, sometimes it's water vapor, depending on the temperature. We're going to assume that that makes water vapor. And most of the time, our organics are going to take the form of either C something H something, or C something H something O something. Those are going to be what we look for in organics. So when you see a hydrocarbon, we're thinking combustion. Now, there's also some nomenclature associated with nomenclature. There's some nomenclature associated with combustion. Of course, combustion, when you see the word combust, that means combustion, but there's some other secret words we use like burns. Burns would mean combustion, ignites, explodes. These things all would indicate that we have a combustion reaction. So when you see, hey, something is burning, we're saying, hey, it's reacting with oxygen and it's going to form carbon dioxide and water. Okay? And that's really all there is to it. So let's take something like methane. What is methane? Well, meth is one carbon, four hydrogens. Methane combusts, means it's going to react with oxygen. What will it form? Carbon dioxide gas, plus we'll assume it is water vapor, meaning steam. Now the trick comes in balancing. Okay, I've got four hydrogens here, so I'll put a 2 over here. So now let's put my hydrogen. I have 4 here and 4 here. Now over here I have what? I have one carbon and one carbon. Okay, one carbon, one carbon. Now oxygens. On my right side, I have 2 times 1, so that's 2, and 1 times 2 is 2, so I have 4 oxygens, and this side I have 2. Okay, so I have to do that. There we go. So this is my balanced equation for methane, and it would be what? A combustion reaction. Great. Let us do this combustion reaction. Ethane gas. Okay, ethane, I remember ethane. Ane means that it is a single, all single bonds, right? That means it's going to take the form of CnH2n plus 2. F means what? I have 2 carbons, so that means C2. H, so I put in 2 here for, so H6. There we go. So I have C2H6. So I have C2H6. What is it? It is gas. And what does it react with? Well, it's combustion, so that means it's going to react with oxygen gas. And what's it going to form? Carbon dioxide gas plus water vapor. Good. Now let's balance this. I have 2 carbons, so let's put a 2 here. I have 6 hydrogens, so let's put a 3 here. Now let's take a look at my oxygens. 3 times 1, so I have 3 here. And 2 times 2 is 4, so that means I have 7. And oops, how do I get 7? Oh man, this is a problem, because then I'd have to have what? 7 halves oxygen? Well, we don't usually like that when we're writing our balanced equations. You can later in the year use fractions, but right now we are not going to use fractions as coefficients. So how do I get rid of that? I'll multiply everything by 2. So I'll have 2 ethanes plus 7 oxygen gases, yielding what? 4 carbon dioxide gases plus 6 water vapors. Let's see. So I have 12 hydrogens. It's 12 hydrogens, 4 carbons, 6, 10 oxygens. It better be 6 plus 8. Sorry. 6 plus 8, 4 times 2 is 8, and 6 is 14 oxygens, and 14 oxygens. Yee-haw! I like it. You guys do this one. Okay, the complete combustion of propane gas. Here we go. Ane, that means I have a alkane. Alkanes are CnH2n plus 2. Prop, that means 3. So I have C3, so 3, 6, 7, 8, H8. So I have C3H8, and that is what? Gas, plus oxygen, yielding carbon dioxide gas, plus water vapor. And let's balance this. I need 3 carbons and 8, so 4 of these. 4, 6, looks like that is 10 oxygens, so 5. Hey, that's an easy balancing. Excellent. I hope you all did well on that. Last one for today. Give it a shot. Okay, here we go. You're going to need my help a little because you haven't seen an ol. Well, ol just means that you have an alcohol. Alcohol. So meth means I have 1 carbon. Ane, that means they're single bonds. Hydrogen, hydrogen, hydrogen. How do I make this an alcohol? Well, there's one oxygen in there, right? So that is my methanol. And what is the equation for this? CH3OH. Okay, CH3OH. I'll probably give you most of these alcohols. It doesn't hurt to memorize them. And remember, all you're really doing is you're sticking an oxygen in between your carbon and hydrogen. Now, let's balance this. CH3OH, and it is a, oh, I don't tell you, it is a liquid, plus oxygen gas. And what's it going to form? Carbon dioxide gas plus water vapor. Great. Now we have to be careful about balancing. You'd be surprised how many people get messed up because we have this little oxygen here. Well, let's start off, go easy. How many hydrogens do I have over here? I have 4. So we want to put a 2 in front of here. Okay. I have 1 carbon, 1 carbon. Now how many oxygens? I have 2 oxygens, and 2 times 2 is 2. So I have 4 oxygens over here. But notice on this side I have what? 1 oxygen and 2 oxygens. So that's 3 oxygens. Ooh, man, how do I make 3 oxygens equal 4 oxygens? Well, certainly not that way. So what do we have to do? Well, in this case, I am going to start all over. Right, instead of a 1 in front of here, I'm going to put a 2 in front of here. Got it? Good. So now, 2 carbons. So carbons, I have 2 carbons. So what do I have to do on this side? Put a 2 over here. So my 2 hydrogens. I've got 3. I have 4 times 2. So I have 8 hydrogens. So I need to make this a 4. Because I have 2 hydrogens into 8. Okay, good. Now, how many oxygens do I have? Well, I have 4 times 1, so that's 4. And 2 times 2, and that's 4. So that means I have 8 oxygens over here. So that's 8. And what do I have over here? Well, I have 2 times 1, so that's 2. So 2 minus my 8, so that means I need to get 6 out of this guy. How do I get 6 out of 3? Got it? Okay, 3, 6. Yay! 2, 3, 2, 4 is my balanced equation. That's it. That's all there is to decomp and combustion. Next time we'll get into single replacement. Thanks, folks. And so it goes.